All right, we're going to continue with anti-differentiation. All right, a little warm up here to talk about general antiderivatives. So they give us f prime x. They want us to find f of x. Remember, the rule is to add 1 to the exponent. So 3 becomes 4, divide by the new exponent. Add 1 to the exponent, 2 becomes 3, divide by the new exponent. Add 1 to the exponent, 1 becomes 2, divide by the new exponent, and the antiderivative of a constant would be 1x, or kx. So the antiderivative of negative 1 would be negative 1x. Don't forget your plus c. Now we simplify. Well, 7 over 4 doesn't simplify. I'll leave it at 7 over 4. 9 over 3 does simplify to 3. 8 over 2 does simplify to 4. Minus x plus c. That is called a general antiderivative. Here are some questions from the homework. You can check those out. They're also in the Teams app. Pause the video and work through them if you like. So as we said before, the inverse operation of differentiation is called antidifferentiation, and we had an intro to that in the last unit. We were working with general antiderivatives. Today we're going to look at something called the indefinite integral or indefinite integration. It is essentially the same thing as the general antiderivative. So same rule applies. It's just going to be set up. The setup looks a little different. General antiderivative. Derivative. Okay. What you'll notice is this integral symbol. All right. This symbol right here is the integral symbol. So what you'll see is the integral sign, what you want to integrate, right? The integrand it's called. The dx is the variable of integration, and then you'll write equal. So when you see this, you don't have to write like capital F of x equals. You can just write whatever the antiderivative is. Don't forget your plus c. Okay, so it's an indefinite integral, and I'll show you what we mean by eventually we'll get into doing definite integrals, but for now let's just focus on the indefinite integral. So here's one, f prime x equals f of x is going to equal, add 1 to the exponent, 1/2 plus 2 over 2 would be 3 over 2, and now I'm going to divide by 3 over 2. Plus 2x to the negative 3 plus 1 is negative 2, divided by negative 2. 5x to the first plus 1 becomes x squared, divided by 2, and this would be negative 1x plus c. 8 divided by 3 over 2 is really like saying 8 times 2/3. 8 times 2 is 16 over 3. And the 3 over 2, or x to the 3 over 2 would follow. And positive 2 divided by negative 2 would be negative 1 over x squared. I sent the x to the negative 2 to the bottom. This would be 5 over 2x squared, doesn't change, minus x plus c. There is my general antiderivative. So this is called the general antiderivative. This is called an indefinite integral. It's basically asking you the same thing. All right. Only I don't have to start with little f of x and go to capital F of x, or start with f prime x and go to f of x. I can just write it equals, all right, and I'm going to add 1, same rule applies. So 5 over 6 plus 6 over 6 is 11 over 6. Then I'm going to divide by 11 over 6. This would be negative 3x to the 9 over 2 plus 2 over 2 would be 11 over 2. Divide by 11 over 2. X to the negative 5 over negative 5. minus 3x to the negative 1/2 plus 2 over 2 is 1/2. Don't forget your plus c. Okay, it's just an indefinite integral. And now I'm going to clean this up. 6/11 x to the 11 over 6. Negative 3 times 2 over 11 would give me negative 6 over 11 x to the 11 over 2. Positive 1 divided by negative 5 is negative 1/5. And the x to the negative 5 would go to the bottom to become a positive 5. Negative 3 divided by 1/2 is like saying negative 3 times 2 gives me negative 6. X to the 1/2 or root x plus c. Two different ways of doing the same thing. General antiderivative, indefinite integral means the same thing. Okay, so we've looked at these guys. Now we're going to focus on these guys here. All right, so the indefinite integral of 5e to the x. And remember, this just means you're integrating with respect to x. So it's this rule right here, the fourth one down. It's a e to the kx is equal to a divided by k times e to the power of kx plus c. So in this case, my a value is a 5. My k value would be a 1. So I would go 5 over 1 e to the 1x plus c, or 5 e to the x plus c. Easy enough. And it says note constants do not change these, but powers do. So we'll start out basic. All right, we'll move into some more complicated ones as we get going. 10 over x, that's the third rule in your table of general antiderivatives. It's this one. Show you why I can't do this. So a lot of people think that I can just write it as f of x equals 10x to the negative 1, because that's what I typically do when there's an x on the bottom. And then my antiderivative, watch what happens here. It'd be 10x to the add 1, 0 over 0. No good. Okay, that doesn't work. We have a rule for that. And as I said, it is rule number 3 in your table of general antiderivatives. We use the natural log function. So it's a over x. It's a in this case is 10. So it would be 10 ln. Capital F of x would equal 10 ln absolute x plus c. General antiderivative, when you're going from little f of x to capital F of x, when you have the integral sign and you go from the, you want to find the indefinite integral here. So indefinite integral, antiderivative, same thing. This would equal a is 1, k is 10, so it would be 1 over 10 e to the 10x plus c. All right, this is going to equal 1 over 5 e to the 5x. Now I won't write the plus c until the very end. This would equal negative 4 over 6 e to the 6x. So my a value is a 4, my k value is a 6. A over k, 4 over 6, e to the kx. Now let's look at this guy. Sine 12x. If I go back, sine 12x. So I'm looking down the left-hand column for something that has sine in it. So a sine kx, it's a over k, negative a over k, cos kx. So I need to use this rule right here. Okay, so let's have a look at that. I'll just copy that and bring it over to the next page. Where's my document camera? All right. So it's a sine kx becomes negative a over k cos kx. In this case, my a value is 1, my k value is 12. So it's going to be a positive, it's going to become a negative, negative 1 over 12 cos 12x. Now think about this. If you do the derivative of the cosine of 12x, that would be a negative sine 12x times 12. But then you'd have to multiply by this negative 112. So that negative 112 times the negative 12 would give you positive 1 sine, or positive 1 sine 12x. Okay? Going to move on to the secant squared. So we've got this one, now we've got this one. A secant squared kx is equal to a over k tangent kx. So a secant squared kx is equal to a over k tangent kx. So my a value is a negative 1, my k value is an 8, so this would be negative 1 over 8 tangent 8x, and now I'll write my plus c. And I'll clean this up, 1/5 e to the 5x minus 2/3 e to the 6x minus 1/12 cos 12x minus 1/8 tangent 8x plus c. Now, remember, if you do the derivative of this line, you should get this line. So if I did the derivative of this, this would be 1/5 times e to the 5x times 5. This would be negative 2/3 times e to the 6x times 6. This would be negative 1/12 times the derivative of cosine 12x would be negative sine 12x times 12. And this would be negative 1/8 times the secant squared 8x times 8. So check this out, 1/5 times 5 gives me that e to the 5x. Negative 2/3 times 6, that would give me negative 12 over 3, negative 4 e to the 6x. Negative 1/12 times this negative 1 would give me positive 1/12 times 12 would give me 1. So I'd have plus 1 sine 12x. And negative 1/8 times 8 would give me negative 1 secant squared 8x. The derivative of a constant would be 0. Okay, so this is what we want to focus on. Antiderivatives or indefinite integrals. Indefinite integrals when you see the integral sign. One last one. Okay. The antiderivative of x cubed, that's a power rule, right? So we would add 1 to the exponent, divide by the new exponent. Same thing here. Add 1 to the exponent, divide by the new exponent. This is the ln x, so 2 over x becomes 2 ln absolute x. And this is a over k, so 7 over negative 2 e to the negative 2x. Don't forget your plus c. And now I'll clean it up. It equals 1/4 x to the 4th minus 9/4, and the x to the 4th would go on the bottom here, plus 2 ln absolute x minus 7 over 2. And I'd even bring this down here, e to the 2x plus c. Okay, so that's just more practice doing indefinite integrals, general antiderivatives, but we've added a few new twists instead of looking at a few more of the general antiderivatives from the table. And I think you might run into a couple extra ones in the questions from the homework, but so far we've looked at those 6. So you can do page 408. Now you can move on to 4, 5, 6, and 7.